Now, let's look at the equilibrium constant, the capital K. We said that when the system has reached equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. So we have to be able to write the K expression for the reaction. Okay, let us consider this equation. We have A reacted with B, produce C plus D. So this is the reactant and this is the product. So the K expression or Kc expression is equal to concentration of C, power of its coefficient, multiply with the concentration of D, power of its coefficient, over concentration of A, power of its coefficient, multiply with concentration of B, power of its coefficient. That is how we write the Kc expression. What is the significance of the value of the equilibrium constant? Okay, the value of the equilibrium constant or K reflect a particular ratio of the product concentration to the reactant concentrations for a reaction. The value of K will indicate the extent of a reaction or how far a reaction proceeds towards the product at the given temperature. K is expressed in terms of the ratio of the products to the reactant. K is unitless. So we can express the equilibrium constant either by using Kc or Kp. Okay? C is for concentration, P for the partial pressure. It depends on the information that we get in the question. If the information that we have in the question is the concentration information, so we can write our expression by using Kc. However, if the information that is given to us in the question is the partial pressure of the gases component in our reaction, so we'll write the Kp expression. So Kc is equal to the concentration of the products, power of their coefficient, over with the concentration of the reactants, power of its coefficient. As for Kp, it is equal to the partial pressures of the products, power of their coefficient, divided with the partial pressure of all reactants components, power of their coefficient. If the value of K is less than 10 power of negative 3, we conclude that we have a small K value. It means that the reaction produces a little product, or we can say that the reaction is hard to proceed or no reaction occurs. If we have a large K with a value more than 10 power of 3, we said that the reaction yields more products. Or we said that the reaction goes almost to the completion. Only little reactants that remain at the end of a reaction after the system has reached equilibrium. However, if we have the intermediate K, when the value is between 10 power of negative 3 to 10 power of 3, we said that the reaction yields a significant reactants and product. It is easier to be observed by looking at this figure 17.2. Okay, let's look at the first one. Okay, this is a reaction from blue particles turns to red particle. Okay, this is a figure when the system has reached equilibrium, in which we observe that there is only one red particles here. It shows that this reaction, this forward reaction, is hard to happen. Okay, even the system at the equilibrium, we have a very small amount of the product that is produced. So we said that this reaction is favorable to the reactant and it has a very small K value. Okay, now let's look at the figure B. This is a reaction from orange particles turns to green particle. So this figure is when the system has reached equilibrium, when we observe that there is only one reactant particles or orange particles presents when the system at the equilibrium, shows that this reaction favor to the product. It have a very large K value. As compared to the last figure, which is figure C, it is a reaction from black particles turns to green particle. So when we look at to this figure, we have a balanced amount of the black particles and green particles. It shows that this reaction has an intermediate K and it is balanced to both reactant and product.